Graphs of sine, cosine, and tangent functions. You will find this on page 152 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Graphs of sine, cosine, and tangent functions. The trigonometric graphs are functions. They are used to relate the angles of a triangle, theta, to the lengths of the sides of a triangle, sin theta, cos theta, and tan theta, to that ratios. They are defined as functions because for every input value theta, there is only one output value, for example, sin theta. Therefore, the ordered pair theta, sin theta, can be graphically represented on the Cartesian plane. Now, the graphs of y equals sin x, y equals cos x, and y equals tan x. Many properties of trigonometric functions can be seen from their graphs. To draw the graph of a trigonometric function for a specified interval of angles, we can construct a table of values first, then plot the points and join them with a smooth curve. Let's look at the graph of y equals sin x for x bigger than 0, smaller than 360. A table of values for plotting the graph is shown below. So you just get an interval. Can be 15 degrees, can be 30, can be 45, but in this case I made it 30 degrees. So it's 30, 60, 90, 120, 150, 180, 210, and so I move on. Then I press on my calculator. Just make sure your calculator is on degrees. Then I press sin 0, I get 0. Sin 30, I get 0.5. Then I go and I plot every point. And then I just take a free-handed and I draw a smooth curve. But very important, and this is why it will be good if you look in the investigation. This is not stopping there. I just stopped there because I just created this table. But this is periodic. It goes to this side as well as to this side. So the graph of y equals sin x oscillates up and down. The maximum value of sin x is 1 when x is 90 and the minimum value is -1. So it's between 1 and -1 when x is 270 degrees. So the range of values of sin x for between 0 and 360 is -1 to +1. Half of the difference between the maximum value and the minimum value of the graph is called the amplitude of the graph. So basically what they say, the maximum is 1, you take the difference, the minimum, then you get 1 plus 1, and then you take the half, and that will then be 1. Okay, the graph has an amplitude of 1, what I showed you there. Then the sine curve repeats itself every interval of 360 or 2 pi in terms of radians. A function that repeats forever is called a parabolic function because it's going on and it's going on. The length of the interval over which the curve repeats itself is called the period. So this is the period between 0 and 360. Then it will start repeating itself. Okay. This is a nice, I just want to show you, this is a very nice investigation just to see how all the graphs look. So you can just with a cell phone or something scan that QR and then you will see this investigation. Or I think no, I don't think there's a link. Yes, there's the link. You can also type in that link if you want to look at it on a computer. Okay, but I'm just going to look at the outcome of the investigation. And I'm going to make it a little bit bigger. Okay. So, the investigation reveals the following properties of the three trigonometric graphs. It's very good if you memorize the basic shapes. It will help you when you start transforming the trigonometric functions. Okay, let's look at this. The maximum, okay, so this is how the graph looked in the investigation, and it can go on and it can go on. So the maximum value of sin x when x, so where is the maximum values? it's there, and it can go on. But in this case, it was 270, 90, 450. And the minimum values, where was the minimum values? There, even there. So negative 450, 90, and 270. The amplitude is 1, because can you remember, it's half of that difference. So it's 1 minus 1, so it will be 2 divided by 2, which will give you 1. The period, when does it start repeating? And I'm going to use, where's my pen? I'm going to use a highlighter. So this is the one, but it's not to say, I can even draw, you see. Okay, there's another one. Do you see? So every 360, you will see that the graph is start to repeat itself. Okay, so that's why the period is 360. What is the domain? That's the x values. So it can take all the x values. So that's an element of real numbers. What is the range? It only exists between 1 and negative 1, the y values, and that's why I write it like that. Okay, let's look at the next one. Again, I'm going to make it a bit bigger. Okay, y equals cos x. Now, actually, cos and sin, and I will show it down now there, they are almost like friends. Now, they have a lot of properties, which is the same. But let's first look. Instead of starting at 0, it starts there at 1. And it looks like this. The maximum value of cos will occur again. Where is the maximum? There's a maximum. Okay. Seems to me this is first clean. Okay. So where is my maximum? You can say negative 360, 0, 360. Where is the minimum values? It's there, it's there, it's there. So it's negative 180, it's 180, 540, and it can continue. That's what I showed you. What is the amplitude? It's the same. 1 minus 1, it's 1 plus 1 divided by 2, 2 divided 2, and that's 1. What is the period? Again, now I want to show you again, because look there. And then it starts repeating. And look there. And then it starts. So again, it's at 360, the period, or 2 pi. What is the domain? It can take again all the x values. But what is the range? The y values, it's just between negative 1 and 1. Now, this is very good if you remember it. The sine and the cosine graphs are almost like good friends. They follow each other exactly 90 degrees. So it's almost like this sine one okay, now how can you say it? Okay, there, it's almost like this one, this cosine one, if I move the cosine one 90 degrees to the front, it will become the sine one. Or if I take the sine one and I move it 90 degrees back, it will become the cos x graph. Okay, so just take note of that. They're just 90 degrees apart. And then the last one, total difference. Total difference. Look at this one. Beautiful graph. Okay, doing his own thing. So if you look at this graph, this is very interesting, because this graph also have this. It's striving to this dotted line, but it's an asymptote. It will never intersect it. Okay, and I'll show you later in the chapter why, and when we come more to the when we do it more in a Cartesian plane. Okay, but for now, just take note. This asymptotes, and this is very important that you notice them. I'm even going to highlight them. They are there. There is one. Do you see? Ooh. And there is one. I'll show you now the degrees. That's the asymptote. But it will never intersect. Actually, I'm making it too big, because then it will cross maybe the graph. Let's rather make it like this, a ruler, and then we rather just do this. Then it stays thin. Don't become too big. Oh, sorry. Okay, maybe my graph will be, but it's not touching. Very important. Although it maybe looks like it's touching, It's not touching. Okay, you saw it. I'm rather going to leave it, otherwise it's touching. So y equals tan x is undefined at negative 270. There, negative 270. There is negative 90. And there it's 90 and 270, and it can continue. Okay, the odd multiples of 90. Interesting. So y equals tan x has no maximum or minimum value because it's going up, up, up. It's just going down, down, down. The value of tan x can be any real number. Therefore, the amplitude of tan x is undefined because you don't know what's the maximum, you don't know what's the minimum. The period, very interesting. If you see, when is it repeating? And there it's, okay, I don't want to make it red, rather yellow. Yeah, and I'm at red again. Just go to yellow. But it's between negative 90 and 90, so that stretch will just be 180, not 360. Very important. The domain, it's all real numbers except where it the asymptotes. So 90 plus k 180, and that k can now be any number. It's 1 or 2 or 3. So just take note, k 180. The range is y's element, so it can be any number of y. Do you see that? And then I just want to quickly check this one. 90 plus, so if it's 0, I'm just sorry that I go back. I just sometimes want to explain it to you. Let's just go, so if it's 90 plus say 2, 180. Can also now be negative 1 or negative 2. So I just want to check it quickly. 2 times 180 plus 90, it's 450. Okay, so odd multiples of 90, and if it was 1, so it was 180 plus 90, it's 270. Okay, so but it can also be negative 1 and negative 2. Just take note, that value of k. The graph approaches the vertical lines, x this, 90 this is now the asymptote, so it's striving to it, but it's never crossing it. These lines are called the asymptotes of the graph. Okay, let's look at an example. On the same diagram, sketch and label the graphs of y equals tan x and y equals negative tan x for the interval negative pi radians and positive pi radians. Okay. Let's first do that. Construct a table with the intervals of pi over 4. It is just a sketch, so only the shape is important, and going through some points, you can use a ruler and draw an x-axis and y-axis, or you can use square paper. Okay, now first we're going to write. So every quarter, so if I start at negative 1, then negative 3/4 pi, then negative a half, negative a quarter, 0, a quarter, a half, 3/4 pi. Now, if you press, don't forget that you have to set your calculator to radian mode. So just go and say tan negative 3/4 pi. So press this on your calculator. So on radian mode, just press tan bracket negative 3 divided 4 multiply pi, close the bracket, and what do I get? 1. If I press this, now I want to see if it's giving you maths error. I think so. So it's going to be tan bracket negative 0.5 multiply shift pi, close the bracket, maths error. That is giving you that asymptote. Okay. And then you do it with each one. You do it also with the just put the negative in front. So in this case, if you do, say for example, this one, so you say negative, no, that 0 is just going to be 0. Let's try this one. So say negative tan and then bracket negative 0.75 multiply shift pi, close the bracket, equals, and it's negative. But actually it's just multiplying these values with negative 1. Okay, then I plot the points. And so I start in that case. So it's 0 and then it's 1. And then nothing. And where you see nothing, you make a dotted line, and that's the asymptotes. Okay. So then I go to the next one, And that's why I say it's very important that you know the basic shape. You have to know that the shape is more or less like that. So, because you're just plotting that point, and then you're plotting this point, and you're plotting this point. So it's good to see that it's striving, it's going a little bit on to that asymptotes. And the same you do here. So if you look at that one, okay, because you have just that point and that point. Then you do the same. Now, if you look at the sketch, before we go on, you can see that this is a reflection in the x-axis. And now I say, describe the transformation of the graph of this, the two tan and negative tan. So the graph is a reflection of the graph in the x-axis. Okay. You can stop the video and you can do try now 10 number 2. Just get my pen. You can continue the video as soon as you are finished. I think the best will be to use block paper or you can even use graph paper. Okay, let's start. So first we are going to create the table. So let's just get the table. It's going to be 3 blocks. I think it's enough. Okay. Okay, this worked out perfect. Now let's first get this is our x. Let's get my pen correct. Okay, so if I'm going to look, and this is going to be, take another color. This is going to be y equals cos x. Let's take another color. Y is equal to negative cos x. And I'm going to work in 90 degrees. So I start at negative 360, then I go 90 back, negative 270, negative 180, negative 90, and 0. Okay. Now, don't forget to put your calculator on degrees. Look always at this. If you see that this range is it's in degrees, then you work in degrees. Put your calculator on degrees. So just go and press cos and put it in bracket. So say, okay, I just want to, sorry, my calculator is now not on degrees. Okay, now it is. So say cos and then bracket negative 360. It's not necessary even for the bracket, but it's going to give me an answer of 1. And then I say cos negative 270 and I get 0. And then I say cos negative 180 and it's negative 1. And then I say cos negative 90 and it's 0. And then cos 0 and that's 1. And then I press on my calculator. But just remember, actually it's just taking that values and multiply it by negative. So it's going to be just negative 1, this stays 0. This becomes positive 1, this is 0. And this is negative 1. Okay. And now I'm just going to do my sketch. So if I do my sketch, let's just see. I think we can work it. I just want to get my ruler again. Because it's going to be now almost like this. And then I have also this. Okay. And if I'm going to mark it now, I'm going to say, okay, this is 0. And then I can, I think it's, you can just do it like this. Negative 90, 2 blocks. And 2 blocks, it's negative 180. 2 blocks, it's negative 270. 2 blocks, it's negative 360. Okay. And now, don't forget, I have 0.5. And I have 1, and I have negative 0.5, and I have negative 1. Okay, so let's start with the green. So I have negative 360, 360, there's my 360. So negative 360, and that was 1. I like the little cross. And then negative 270, and that was 0. and then negative 180, and that was negative 1, and then negative 90, that was 0. Now I see what's my, it was looking too far, so now I see I was not very accurate there. Okay, now it's looking better. And then at 0, it's 1. And now, that's why it's good if you know the basic shape, because now you know that shape. Sometimes it's a bit more challenging drawing it on this board, because I cannot rotate like you can maybe rotate the paper. Okay, yeah. Don't say it's my base. I just want to, yeah. Let me try it another one. Yeah, let me rather go from here. As I said, it's a bit more challenging with my technology. Okay, but that's good enough. Then this one was now negative 360 and negative 1. And then also 0, and then negative 180 and 1, and negative 90 and 0, and then 0 and negative 1. And now it's just doing almost the opposite. Can you see it's a reflection? Okay. Let me just get that. Okay. I think this is what I can do. Let me just, I always like to write it in. So I always write y equals negative cos x. And then this one, y is equal to cos x. And now describe the transformation of the graphs this. And then I just say, therefore, this was number A. And number B. So y equals negative cos x is a reflection of y is equal to cos x in the x-axis. Okay, and that is how you do it.